Bismillahirrahmanirrahim. The next topic of our course Digital Electronics this is our lecture 8 basically. Now we will study the addition and subtraction. In addition we will have half adder, full adder, and in subtraction we will also have half subtraction and full subtraction. So we are starting our topic with half adder. So this is half adder, which says that we will have the two inputs A, B, two inputs. We will do the half adder and we will get the result carry and sum. We will have the two results. This is related to the simple addition we do in maths. So A, B, carry, sum. 0, 0, 0, 1, 1, 0, 1, 1. Now we will add them and we will have our results carry and sum. 0 plus 0 is equal to 0. Sum is 0. कोई carry नहीं लिया है, so carry is also 0. 0 plus 1, 1, no carry, 0. 1 plus 0 is 1, no carry, it's 0. 1 plus 1 is sum is equal to 10. 0, 1. As we know, the sum of 1 plus 1 is equal to 10, and the sum of 1 plus 1 plus 1 is 11. Okay, so this is our half adder. Now we will do the circuit diagram for it. In this we have to see our carry, which is the AND gate. You can check it out. 0 into 1, 0, 1 into 0. 1 into 0 is 0, 1 into 1 is 1. And for sum we have the XOR gate, as we have studied it in our previous lecture. So AND gate, we will draw the AND gate with input A and B, A, B, and this is our carry. We will draw the circuit A, B. Now we will draw the XOR gate, and this is our sum. This is how we draw the circuit diagram of half adder. It says that whenever we have the different inputs, the output is 1. And on the same inputs, the output is 0. This is XOR gate, this is its symbol, and this is for the sum, and we have drawn it. This is the diagram, this is the table we draw for it, and this is the circuit diagram for the half adder. Now we will study the full adder. Okay, this is full adder. In this we have the three inputs A, B, C, and the output is same, carry or sum. Now we will fill these blocks. They have 0, 0, 0, 0, 4, 0, and same 4, 1, 4, 1. 0, 0, 0, 1, 1, 0, 1, 1. And again we will repeat it 0, 0, 0, 1, 1, 0, 1, 1. Now we will do the carry or sum as we did for the half adder. So this is 0, 0. 0 plus 0 plus 0 is equal to 0, 0. No carry, just sum. 0 plus 0 is 0, 0 plus 1 is 1. Again 0 and 1. 0 plus 1, 1 plus 0 is carry 0, and the sum is 1. 0 plus 1 plus 1. In this, we will have the 1 carry and the sum will be 0. 0 plus 1 is 1 and 1 plus 1 is 10. As I told you before that 1 plus 1 is equal to 1 0. 1 plus 1 plus 1 is equal to double 1. So this is 1 0. Again this is 0, carry 0, sum is 1. 1 plus 1 again 10. 1 plus 1 is 1 0. And for the triple 1 we have is 1 1. This is our table for the full adder. And now we will do the circuit diagram for it. And before making the circuit diagram, as we have the 3 bits and the carrier sum, we will first draw the K maps for it and then we will draw the circuit diagram, so it will be more easy for us. We will first make the K map. So for it we have the 3 inputs, which says that A, B and C. 0 0, 0 1, 1 1, 1 0. And for C we have 0 and 1. Now we will fill these boxes by the help of this table we have. We are making this K map for carry. So we will see the results of carry. When both A and B are 0 and C is also 0, we have 0, 0, 1, 0, 0, 1, 0. Carry is 0, double 1, 0. This is double 1, 0. Carry is 1, for 1, 0, 0. Carry is 0. And for 0, 0, 1 we have 0. For 0, 1, 1 we have 1. For triple 1 we have 1. For 1, 0, 1 we have 1. Now we will make the groups. This is the group 1. This is the group 2. This is the group 3. As we have studied before, we will write this group 1 AB, group 2 A, B bar, C, and the group 3 is A bar, B, C. Group 1 A, B bar, C, this A, B and C is changing, we will not write that. Group 2 is A, B bar, C. Group 3 is A bar, B and C. Now we will simplify it further. Okay, we are simplifying it further. That says A, B plus C into A, B bar plus A bar, B. We take C as a common. So we have C into A, B bar plus A bar, B. Now to do it more simple, so it will be easy for us to draw the circuit diagram. So we are using A, B and the XOR gate, A XOR B. It is basically the XOR gate. I can prove it here. 0 0 1 0 1 1 0 and 1 1 0 1 1 0. Which XOR gate says? It says that whenever we have the same inputs, the output will be 0. So we can write it now. We will write it as A, B plus C into A XOR B. It will be easy for us to draw the circuit diagram. Now for the sum, you will fill the blocks by the table we draw before. So 3 inputs A, B, C, 0 0 0 1 1 1 and 1 0. For C we have 0 and 1. The results we have from the table are these. So now what this says, there is one more important point. To it we say is checker board pattern. Okay, in checkerboard pattern we have 0 1 0 1 1 0 1 0. Whenever we have this in our K map, we will have the checkerboard pattern. After 1 there is 0 and after 0 there will be 1. So this is checkerboard pattern which says A XOR B XOR C. This is what checkerboard pattern means. And if there are 4 variables, we will add one more B, like this. We will have to add the XOR gate. But now here we have 3 inputs, so this is our expression. Now we will make the circuit for the full adder circuit. First we will draw for the sum, and then after we will draw for the carry. So see it carefully. This is our result of the carry. But first we are doing the sum. So A XOR B, we will have A XOR B. Now we will add the C in it, like this. 2 wires. This is C. This will be A XOR B XOR C. Now for the carry, we will have the A, we will have the B. First we have our AND gate, A dot B. Then we have A XOR B with C. So A XOR B and C. There is the AND gate between it. This is C into A XOR B. You can see there is the AND gate between it. Now we will have OR gate between these two expressions, this expression and this one. We will have the OR gate here, like this, and this will be our final expression, which says A dot B plus C dot A XOR B. This is okay. Now this is our full adder circuit diagram, our K map and our circuit diagram. And in our next lecture we will study the subtraction, half subtractor and the full subtractor.